Hi everyone, myself D. Devasugamani, Assistant Professor, Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to discuss about control valves. And these are the contents which we are going to discuss today. First of all, what is meant by control valve, construction and working of control valve, and control classification, types, and industrial application. Finally, the selection of control valves. First of all, what is meant by control valve? Control valve is a mechanical device mainly used for the purpose of control the process or regulate the process. And the control valve is an integral part of any applications, any flow applications. Apart from that, it performs the following functionality like starting and stopping the flow, varying the amount of flow, as well as vary the temperature also, and control the direction of flow, as well as totalizing the flow. And it can be act as a safety purpose also, like a vacuum or pressure safety valve also it can be used. And these are the parts of control valve. This is the actual lookout of control valve. Control valve basically classified into two parts. First one actuator, another one is valve body. Let us see one by one. This is the cut view of a control valve. Actuator is nothing but the primary element of any control valve. It consists of diaphragm and spring where the energy has been traveled through this device. This is the primary element of any control valve. And actuator is nothing. There are three types of actuators here. First one, pneumatic, hydraulic and electric, where the energy has been changed based on the actuator type. Pneumatic in the sense air, and hydraulic in the sense oil or water, and electric in the sense motorized control valve. And followed with control valve body, and it's been constructed with the help of valve stem, where the valve is seated here. And the second element is called as body, where all the elements has been housed here. And these are the actual lookout of control valve. And this is the control body. It houses entire elements. So this is the control outer structure, control body, and this is the disc. So control valve is classified based on the disc shape and size. Each and every type has been changed based on the disc assembly. And this is the valve seat where the disc is seated here. When it's seated, it's completely closed down. There is no exhaust of flow. And this is the bonnet where the pressure recovery takes place. Pressure is completely retained on this area. This is called as bonnet. And this is the packing assembly. And this is the control animation. And this is the actual lookout of actual visualization of control valve. And this is the orifice where the flow has been visualized. And control valve consists of two parts. One is valve body, another one is valve actuator. So the primary element is actuator, another one valve body. And when the flow is inserted in the inlet port and is exist in the outlet port, and this is the valve stem where it can be moved from up and down with the help of the energy source like pneumatic, hydraulic as well as electric motor. And it's been moved based on the application of force where it can be moved up and down. It's a linear flow stem where it can be moved from up and down based on the application of force. And there are three types: spring and diaphragm, solenoid as well as motorized control valve. So first we would like see about spring and diaphragm actuator. So at the name itself we can know it's consists of spring as well as diaphragm based. So this is a diaphragm and followed with the spring. The energy has been carried out based on the spring alignment. So this is the inlet supply where we apply the pressure force. Initially we can apply 15 psi here. So once we apply a pressure, the pressure has been connected with the diaphragm where it exists a force. So because the stem is connected here, so the valve getting moved down. So this is nothing but air to close valve. There are another type of valve called air to open valve, where when we apply a pressure, the valve gets open. But here, when we apply a pressure, the valve gets closed. So this is exactly called air to close valve. And moreover we can use a current to pressure converter for sensor purpose. So where the current has been converted into pressure with the help of ITP converter based on the required power supply. Because when we apply a 3 psi here, the valve is completely open, but when it increased to 15 psi, valve is completely closed along with the valve seat. So this is the purpose of using ITP converter. And if we another thing, if we give some marginal range like 9 psi or 8 psi something, if we give 9 psi, the valve is partially open. It's not fully closed. It's been partially open. So these are the different range settings of a spring and diaphragm actuator. And next one is solenoid control valve. So it is very simple and mainly used valve type in nowadays industries. And solenoid is mainly used for the purpose of on-off control applications where the coil gets energized with the help of inlet supply. So when it's energized, it's been completely closed down. If it's de-energized, it's been opened based on the spring movement. So with the help of return spring, the valve plug has been move up and down based on the application of supply where the flow has been resumed. And the third one is electric based control valve, that means electric motor. And this is completely feedback system where the stem is connected with the help of motor and gears. So when the application of supply, the motor gets opened, with the help of a motor, the stem has been moved up and down based on the application of supply where the valve plug has been completely seated down. So when these two voltage has been equal, when these two voltage is equal, in the sense the valve gets opened down and the flow gets resumed. So these are the different type of control valve animations here. And next one, we can move on to control classification. This is the overall classification of control valves. Control valve based on functions. Control valve is classified based on functions like isolation control valves, regulation control valves, relief valve, non-return valve, and special purpose valve. And this is nothing but isolation. See, isolation is nothing but it can be changed either on as well as off condition. It's completely isolated from the application. So where we use the device when it's completely open and closed down with the help of isolation valves. And regulation in the sense varying the flow has been varied based on the application of user requirement. And third one is relief is nothing but safety purpose. Okay, whenever we apply whenever the pressure is maximum, the valve is automatically opened down in order to safeguard our device. And the next one is non-return valve. Non-return also mainly focused on safety purpose, mainly used in oil and gas industries for the prevention of backflow. And the last one is special purpose valves. So these are the special purpose valves where we can use some special applications like pharmaceutical and some design based applications. And these are the actual valve diagrams of control valves according to usage. This is isolating valves like gate valve, plug valve, ball valve, and sometimes the valve plug has been used in both isolating as well as regulating valve. And these are the special purpose valves. And next one is valve operations. The valve is operated with the help of hand lever, hand valve, chain operated devices, and gear operated. These are the different valve operating mechanisms used in nowadays. And we will see all the valves one by one. First, we can see about gate valve. So this is the actual lookout of gate valve. Gate valve is mainly used for the purpose of fully open as well as fully closed applications where the pressure loss is very minimum. It's been used in all type of small applications. In nowadays, gate valve is exist in all industries and all type of applications. Even household applications also we can use this type of valves. This is the actual lookout of gate valve. And next one is ball valve. So at the name itself we can know that. So this is the ball. So this is the ball shape because the valve plug is completely lookout of ball. So this is the quarter turn. When we move this lever in 45 direction, it's completely open down where the flow gets resumed. And this shape is exactly called as ball shape or ball disc to start as well as stop the flow. So this is quick acting type. And for applications, it can be used for fire safety and shifts. Even for manufacturing industries also we can use this type of valves. And next one is butterfly valve. And butterfly is nothing but this is also one of the type of quarter turn valve. So if we move on 90-degree angle, it's completely open or closed. So this disc has exactly shape of butterfly valve. And so this is the valve where we want to use in a completely shut off applications. This is also a very familiar valve and mostly used in nowadays, especially in process industries. And butterfly valve mainly used in chemical industries and food industry, pharmaceutical industries where slurries and vacuum service, high pressure. So this is famous mostly in the applications of high pressure and high temperature applications. And next one is globe valve. Globe, as the name itself, globe is nothing but, so this is the globe disc, globe valve. And this is also used for stop as well as stop purpose, as well as regulation also we can use it. And it's completely used for tightened applications where the flow can't expose. And applications, globe valves is mainly used for the purpose of sample applications. So this is the exact usage of globe valves in industries, and it's mainly used for manufacturing industries. And next one is diaphragm valve. So diaphragm, see the valve body is called diaphragm body. So this is diaphragm area. And so this is nothing but linear valve. So what is linear means? It can change either in one direction. It's not rotatory motion. It can be moved either up and down based on the application of force. and it's completely isolated from the process fluid. So these are the three working nature of a diaphragm valve. For open condition, when it's open condition, it's completely moved up, and if it's closed completely, it's completely closed down where the flow can't escape. And this is for medium portion in the sense throttling, so where we can change the direction as well as we can change the velocity of a flow. And next one is pinch valve. This is also another category of linear motion valve where the pinch tube is used. So this is a pinch tube. So this tube is nothing but pinch tube where the flow gets exist in this category, and it can be used for the handling of slurries as well as some large amount of suspended solid also. And next one is plug valve. Plug valve is also called as rotational type of valve. It's a rotational category of valve where this is called a plug. When we moved in the either one direction, it's completely open, as well as when we moved in the same direction, it's completely closed. This also has been used in boiler flow, feed water application, as well as for some feed applications also we can use it, as well as corrosion liquids and gas applications also we can employ this type of valves. And next one is check valve. Check valves is one of the famous and also called as non-return valves, and it can be mainly used for the prevention of backflow, and this is the piping and instrumentation symbol for the check valves. And these are the different type of check valves normally used: swing check, dual plate check, and ball check, as well as lift check. And these are the actual lookout of check valve. So this is the check disc. So it's been open in either one direction, but when the flow comes in backflow, it's completely closed. It's mainly used for the purpose of prevention of reversible flow of a piping system, and it prevents the backflow. And it's commonly used type in industrial pumps and fluid application, as well as oil and gas industries also used in order to prevent the backflow. So this is the check valve where we want to use for the prevention of reverse flow applications. And next one is relief valve. As I told already, the relief valve mainly used for the purpose of safety purpose. It's an automatic type of valve. So when the pressure is exceeded at our preset limit, it automatically opened or closed down based on the limit as the user set. So whenever the pressure is maximum reached, the valve gets opened in order to relieve vacuum or pressure in order to prevent our device. And this is the overpressure relief valves. And these are the two types, that is a spring loaded type as well as pilot operated type. This is spring where the pressure gets released based on the spring mechanism. So this is the P&I symbol for a spring loaded type, and this is for pilot operated type. So pilot in the sense it's a piston based operators. So the piston gets moved up whenever the pressure exceeds our limit. So these are the different type of pressure relief valves. And other type of valves also available, like foot valve, flap valve, three-way direction valve, four-way direction valve, and rotary diverter valves also we can use in nowadays. And finally, we have controller selection chart. So these are the categories where we use to select of any control valve for our applications, like what type of fluid we used, required functionality, and pressure, temperature, flow, isolation category, frequency, maintenance, cost, as well as weight. So we can select based on based on user requirement in these industries. And these are the references. Thank you.